Hello everyone, welcome to my channel Cloud and Data with Koshi. So today we are going to start our internship program hands-on training. Okay, so this is from this task is from that data science graduate professional internship program, the Spark Foundation. Okay, so this is my task that I have to perform with the hands-on part in Python. Okay, so first we have to see what the task is. We have to predict the percentage of an student based on the number of study hours. Okay, so what we are going to predict the percentage of an student, how much score he has secured based on the number of study hours and how many study hours he has evolved over there. Okay, so this is the problem statement of simple linear regression. So you all know that simple linear regression involves two variables. So one is dependent variables, another is independent variables. So dependent variable is that percentage, predict the percentage of student, okay, percentage of student, and it's depend on that number of study hours, okay, based on the number of study hours. So this is the task that I'm going to perform, and we can use any tools like R, Python, SAS Enterprise, any other tool. So I'm okay with that Python. So just going to discuss that coding part in Python, okay? And this is the data, and you can see this is my data. Just copy it and you just paste over here. You can see first what the data is. You can see hours and score is given, right? And we have to predict if the number of hours is 9.5. Okay, if the hours is 9.5, then what will be the score? So let's get started. We all are inside my Jupyter notebook, right? So what will be the predict score if a student studies for 9.25 hours per day? Okay, so percentage, how much he has secured, how much he will be secured if he has devoted his time 9.25 per day hours. Okay, how much score he will secure, predict the percentage. So this is the problem statement. This is a problem statement of simple linear regression. It involves just two variables, dependent and independent. Okay, let's get started the task. So first what we will do, so I just write some statement over there so we all can understand in better way. So just taking the markdown cell, and I am using the simple linear regression, right? Simple linear regression. So in this regression task, we will predict the percentage of marks, that a student is expected to score based on the number of hours they studied, and this is simple linear regression task, and as it involves just two variables. Okay, and I'm using I am using that scikit-learn library, linear regression. Just also I'm writing linear regression with Python, scikit-learn. So this is the official website of scikit-learn. So you can see this is the official website. So you also get all details study over here. So regression problem, clustering, classification. Okay. So you can use that. So this library I'm going to use. Okay. So copy and add inside the description link here. And don't worry, I will share that Python file with my GitHub link, so you can also get all the code over there. Okay. So just write what I'm going to perform in this section. We will see how the Python scikit-learn library can be used to implement regression function. Okay. So this is my problem statement, and that problem statement I have broken down into that two ways. It predict the percentage of marks. Okay. And how much time he has evolved, like 9.25 hours, then how much score he can get, right? Let's starting the coding. And you just take one cell. I hope you all familiar with that Jupyter notebook in that VS Code. So just take the code over there. And first importing all the libraries, import all necessary libraries. Okay. So import pandas as PD, import numpy as NP, and we have to import matplotlib. You can see matplotlib dot pyplot, matplotlib dot pyplot as plt. As plt means alias. Okay, you can take alias plt and matplotlib inline. Okay. So these all the necessary libraries that I am going to use in this problem statement. Just click over there. So you can see all the libraries are going to activate and install. Okay. So you can see all the libraries are installed over there, and this is the pandas as PD I'm taking, NP and numpy. This is the numpy, all an array object of arbitrary homogeneous items. Fast mathematical operation over arrays. Okay. So this is the module that I'm using over here. So all the libraries I'm adding. Okay. Next, what I'm going to do. So read the data. Now I am going to read the data from CSV or given URL. Okay, my URL. So what is your URL? So you can see the data URL is there. I already shown the data, right? And here I have to first input. So first step of creating linear regression or any kind of model in machine learning. So you have to input your data, right? You have to supply the data. Otherwise, the no task will be performed. So you have to you have to read the data, right? Not download, you have to read the data. And then this is my URL, okay? This is my URL. Okay? So my data is equal to td. So td dot read CSV on function read underscore CSV td dot read CSV, and you have to supply your URL. And from that URL, I am going to read the data. Okay. And also write print. So just first and click over there. So my data is here in this variable, right? Now I am going to see my data. So first, so just write the data is displaying with first 5 rows. Yeah. So you just write this and then you can my data dot head. Head is one function. By default, 5 rows will come. Top 5 rows. Okay. So dot head and just okay. So you can see 0, 1, 2, 3, 4. So top 5 rows will come. Okay. If you will not mention the rows dot data, okay, not mentioning, just only write my data. So here you can see all the data. But if I want to see that only 5 rows, top 5 rows, then I can use dot head. Okay. Next, same. If I want to see the bottom 5 rows, okay, last 5 rows. So what I will do? Last 5 rows, last 5 rows. That is my data dot tail. You can see 20, 21, 22, 23, 24. Last 1, 2, 3, 4, 5. 5 rows will come. Okay. Now, if I want to see only 2 rows, only 2 rows from first. Okay, so my data dot head and here just pass 2 inside this bracket. Okay, so only it will return 2 rows, 0 and 1. Okay, so how many rows you want to display? You want to see inside your cell, so you have to put that number. Okay, and same only 2 rows from last. Okay, so my data dot tail and 2. So only last 2 rows will be printing over here. Okay. Then we are going to see how many rows and columns are present. So how many rows and columns are present inside my data? So just write how many rows and columns are present inside data. So my data dot save. So you can see 25 is rows and 2 columns, right? So 2 columns means hours and score. 2 columns are present, okay? If you want to see 5-point summary, 5-point summary of my data, so you can write my data dot describe. So this is the 5-point summary, means mean, standard deviation, minimum, 25% quantile, 50, 75 and max. So this is the data 5-point summary, okay? Just describe, right? Next, check is there any null values present or not. So if I want to see is there any null values present or not, so what we will do, so my data, right? My data dot is null dot sum, okay? The count will be present and check there is no null values are present inside the data, right? And if I want to see that information, like the data is data frame or not, the all type of information, the data type, okay? Check the data information. So what will write my data dot info, okay? This very simple command is there, so you can write. And here you can see that float 64 hours, okay? This is the data type and score is integer, okay? And 528 bytes memory is used for this data, okay? And this is the data frame class, okay? You also know this data frame class from there. Also know the data frame class from my data, and here you can write type. What type? Okay. So type also determine the data type or the class or for this data set. Okay, you can see pandas.core.frame.data frame. Okay, so this the data is the data frame structure. Okay, and this data frame is hierarchical structure from pandas. So that is the reason they have written pandas.code.frame.data frame. With that, you can also know the type. Okay, let's see some visualization. So of this data set, I'll write over here and just write. Let's plot so you can understand. So let's plot our data points, on 2D graph to eyeball our data set and see if we can manually find any relationship between the data. We can create the plot. Okay, we can create the plot. We can create the plot with that following script. So here I am using the matplotlib. This is dedicatedly used for that visualization or chart graph things. Okay, the following script. So you can use matplotlib. Okay, so first just taking the code and you can write plotting the distribution. So you have to plotting the distribution of score. Plotting the distribution of scores. Okay. So my data, first I'm write my data dot plot. Okay. And here I'm going to supply x. So x is x and y. Okay. X is equal to my hours. So hours will be print inside the x label. This is my label. X labels and y is equal to that my score. Okay. And normal style, I'm not going to use this style. Okay. And plt dot title. And you have to provide the title. Hours, we have to see the distribution, right? The we have hours and score. We have to see that distribution. So hours versus score, or hours versus percentage of score, right? Percentage you can write. And plt dot x label is my label that will be printing in the x, that will be showing in the x axis. So hours started. And plt dot y label, that is percentage score. Okay. And you can write plt dot show. So it will display the entire chart. Okay, this plot. It will take some time, then it will be printing over here. The display, the plot will be displaying. I got one error. That we might fix over there. This should be x. Y. It's time. Now just, yeah. So I mistakenly put the x as uppercase. Okay. So now you can see. So this is the hour studied in the x level. Okay. And this is the y axis, that is the percentage of score. So from the graph, we can clearly see that there is a positive linear regression, positive linear relation. That means number of hour studied and the positively the percentage is getting higher. So between the number of our studies and percentage of score, this is the positive linear regression. From this graph we can understood, right? So we also write this thing. So if I study more, if I study the number of hours more, so I obviously get the percentage. Okay. So this the simple linear regression relationship is distributed on this graph. Okay, you can see this is the hour studied and this is the percentage of score. So we also write this thing. From the above graph, we can clearly see that there is a positive linear relation. Okay, positive linear relation between the number of hours studied and percentage of score. So from the graph, we can clearly say that we can take the decision, right? So this is my positive linear relation model. Okay, on that study hours and percentage of score, right? Then we have to preparing the data. Next, we have to preparing the data for creating the model, creating that attributes model. Okay, now first we have to preparing the data. So preparing my data. So what will prepare? So we have to divide the data into some attributes, mean inputs, and some labels, means output. We have to distinguish. The next step, I also write. So next step is to divide the data into attributes. That is my input, right? Input and labels. I also write labels. And this is my attributes. Okay, you can see attributes and input labels, that is my output. In the following cell, I am just going to prepare my data. So preparing my data set. Okay, next what I will do, x is equal to my data dot I log dot value, and y is equal to my data dot I log and dot value. Okay. So now we have our attributes and label, right? So x is my, we have to split. The next step, now I'm going first we have to see what the output of x and y. Okay, and just execute the cell. You can get x and y and print the x. So this is my x. Okay, we have divide my data set. So all the data set that divided into x and y, and ilog you can see purely integer location based indexing by selecting the position. Okay, So ilog is very important. You can see that attribute, the property of the Python, right? So you can separate all the data set, or like colon, that means all. Okay, and this value I'm going to take in my x and y. So and dot values, okay, and return a numpy representation of data frame. That means it will return an array. This is my array, right? X is my array, y is also my array. You can see this is my x value, right? And if I going to print my y, so you can see this is my array of y. That means, so first understand this thing. So this is my scores and this is my hours. So simple, I have separate these two things. So hours is separate in the x variable and study and score, right? This is my score. So score is separate into different variable. So we have already divided my data set, right? So I also write here. Now that we have our attributes, okay, and labels. So attributes means what? Attributes is your input, right? And label is your output. So we have successfully divided that attributes and labels. And next step, next we have to split this data into training and test sets. Okay. So we are using scikit-learn built-in 10 state split. One function is there, right? Built-in means you already is there. So you can check in your scikit-learn library or the official documentation. So you can find it out, okay? Scikit-learn built-in then test split this method, okay? So this is my, now I'm going to split the data. You have to take form and 10 test split. I also write, you can also get from here. So go in the new tab. Okay. And just write in scikit-learn and you can get this link and just go over there. So sklearn.model selection 10 test split already is there, right? You get the code also. You can get the examples also, right? So just copy this line. I already inputted the numpy array. So just copy this line. I'm just showing you from the official documentation. So you can just go and you have to just copy and paste over there. Okay. So first you have to import. See, is there any problem or not? So it will take some time. Next what I'm going to write over there. So X train, yes, it executed successfully. Is there no error? And next we have to separate. Separate is done. We have to split the data set, right? So X train, X test, okay. Y train, Y test is equal to 10 test split. You have to supply X, comma Y. So just write. So I'm first 10 test split. I'm right. Okay. So you have to supply your X. You have to supply your Y in that function. Okay. So split arrays or matrix into random 10 and state subset. Okay. So I already get my X value in form of array and Y value in form of array, right? So I just apply over there and test site how much data set you want to kept for the test, right? So this is my test size. So 0.2 means 20% data will be secure or kept for my testing purpose. Okay, so 0.2 and random state is 0 over here. Okay, so you have to add this thing. Now you have to assign this 10 test speed into 4 variables. So like X subset of variables, Y subset of variables, 10 and test. So X 10, X test, Y 10 and Y test. Okay. So I'm just write. So just first you have to create these things and then you have to assign this 10 test split into 4 variables, right? So these first X 10 and X test, Y train and Y test is equal to this value, right? Now just run. So X10, X10, X test, Y10, Y test, we have already split it. So split the 10 test split. So first I'm write split the data set with training and testing set. Yeah. With train test split, and you have to import train test split from built-in method. This is called built-in method, right? Built-in method from sklearn, sklearn, and sklearn, and this is the link that already added, and separately I'm adding this link. We can directly go over there. Okay. Now we have to training our algorithm, right? So just write, mark down, training the algorithm. We have split our data into training and testing sets. And now is finally the time to train our algorithm. So we have now training the algorithm to train our algorithm. Okay. So for the step, first we have to split the data set. First we have to import the libraries. Second, we have to read the CSV file or link that have provided, and we have to take some kinds of how many rows and columns are present, the describe, the summary, all things over there, and then we plot our data in that plotting the distribution model, and then once to see that relationship that is positive or negative relation. Okay. Once it is done, then we have to preparing the data. That means we have to divide the data. And now, one more thing, that we have to split the data in 10 test split from that sklearn library. This selection model I have to taken, and we have to split it. 10 test split. As of now is okay, right? And now training the algorithm. So, linear regression. This is also, you can also search from here. Yeah. Next, that linear regression, right? You have also learned linear regression cycle. So directly you can go this link and just go over there. Okay. So sklearn.linear model and linear regression, that is also inbuilt, that so you have to copy this line, or you have to from the linear regression model. So this is the official documentation of linear regression model. So just copy over there. Okay. Linear regression, and also I'm adding the link over here to linear regression inbuilt model from SQL. You can directly go from this link. Okay. We have to import. Now you have to initiate it or inherit this object, this in that linear regression model, right? So regression is equal to okay. Now we have to initiate it or we have to assign this model inside one regression variable, one inside regression, inside one variable. So any name you can take or inherit. Yeah. Okay. So regression. Before doing that, I just want to see the linear regression type. Okay. So you can see this is the metadata, ABC meta, right? So if I want to write, now you can understood sklearn.linear model based linear regression. So this is the type, okay? This is the model type. We can know we can also we can know a model type. What type of model? This is sklearn.linear model and the linear regression. This class is there, okay? Just and you have to establish this inside the regression. Okay, regression is there. That means, and you can print the regression. Yeah. So you can see this is my linear regression. All the data and all that model that I've created, it is there in the linear regression. Okay. Now take one cell and we have to fit. So fit the model. We have to fit the training model. What we'll do? Regression dot fit. Okay. And extend comma wide. We have to write print training complete. Training complete. Okay. Next step, before going to test the model, you have to plotting the regression line. Next step, that we have to plot the regression line. So plotting the regression line. First, we have to create the line model or line mod. Okay, and regression dot. So regression, this is my this value regression dot coefficient underscore into x. Y is equal to mx plus c, right? Plus regression dot intercept. Okay, the line is creating. So this is that I am going to use over there. Just copy this line, take the code. This is your line, and you have to just 1 minute. Yeah, plotting it. Okay, remove this cell, and we have to plotting the test data. Plotting for the test data. Okay, so plt dot scatter dot plot you have to supply x to supply your line, model, and plt dot show. Okay, next cell, and see what the value of this is the line model. That means this line, right? Prediction line mode. So regression that coefficient into x, and this is the intercept. Y equal to mx plus c. This is my coefficient value. One minute. Yes, so this is my coefficient value. Okay, and for the first and this is my intercept value, right? You can write one line and you can get coefficient, intercept, all values. So this is my coefficient value. Print coefficient value and copy and paste in intercept. Shift value, not intercept, right? So these two values I am getting now. So first is 26.79, right? So how it is coming? So first x value is what? So first we have to know x is my inputs, right? So hours, 2.5. So manually you can write here or take one cell in 2.5 and we can print the y. You can see 26.794, right? 26.794 for the first row. Or if I will devote 2.5 hours, then how much marks I am getting? Also you can write print statement here. Or you can take the F string. Devote 0.5 hours and my marks will be yeah. Same, just copy this line. Hours you have to change over here. Okay. 2.5 was X value, right? Next, five point one. Write 5.1, 5.1 and 52.56, right? You can see 52.56. So 52.56. One by one, it will be calculating, okay? This value. So you are devoting 5.1 hours. So I am writing 5.1 hours, okay? And your marks will be 52. So our model is quite good, prediction is given, right? And now you have to test. And we have to test and create the prediction. Making the prediction now that we already apply, means this is my train model X, all the X value, right? Now we have to test the algorithm. We have trained our algorithm. Simply we have trained our algorithm. Now it's time to make some predictions. Okay. Now we can predict. Take another cell. So y print. Okay. And first we have to see that predict regression regression dot predict. Predict the mode. Predict the algorithm. Okay. So regression dot predict, and what I provide over here, test. Sorry, test. X test. Okay. We have already X10 and trace. And just regression spelling, I have to check its regression. Regression spelling is there. Yes. Now I think right. So regression dot predict. Okay. Now I am applying the test, X test value. Okay. So assign this variable into y underscore predict. Y predict. And we have to compare the actual and predicted value. Now we can compare my actual and predicted value. So this actual and predicted value will show one data frame format. So that is for the better visibility. Okay. And you can also understand these things. So df is equal to data frame. So PD, first I'm writing our data, our actual and predict data. Okay. Second I'll clear this. So forget about these things. Okay. Actual and predict data. So it's my actual. Y test, Y underscore test, and predicted Y underscore. Okay. Next, I will create one data frame to display actual and predicted value. So PD, or you can write TF1 PD dot data frame. Okay. And we just supply this value. This is also the object. Okay. We can also see the type. So just write type dictionary. You have to supply this dictionary. Already known from this type, right? So this is the dictionary type, and just copy and add over here. You can run it. Okay. Next, you can see df underscore 1. Our data frame is ready, and it will display. Okay. $20 hours prediction is there. 27, 69. Okay. So actual is 20 and predicted is 16.88. So you can display your actual and predicted value. Now test with that 9.5 hours, right? So we can also test with your own data. How many hours you will devoting? 9.25 own data predict. So regression dot predict, and you have to pass that 9.25 or hours. And print number of hours is equal to dot format hours. Predicted score score own predict. This is the value, right? Quite good, because 20 is actual and predicted 16. 27 is actual, the hours, right? Why test? You see, just go code. Why test? So 20, 27, 69, 30, 62. Why these values, right? Regression. So we can predict with that hours value. This 9.25 hours, how much score I can predict. So you can see I got one error. Own data prediction like regression dot predict. So what is telling? Expected 2D array got scalar array instead. Okay. What we'll do? I will just provide the 9.25, but it's not a 2D array format, right? So always remember whatever you supply for the prediction, that should be an array. Okay, it should be an 2D array format. Okay, so you can write, you have converted in that array, right? These hours, and copy it in the hours, or you can do one thing, copy entire thing, and here you can write 9.25 and copy the hours. Here you can pass. Okay, let's run. So number of hours, that is 9.25. Okay, and so better you can do one thing, and here you can pass the hours. So that will be, oh sorry, that will be good. And hours 9.25. Yeah, yes sir. Yeah. So number of hour 9.25, then I can predict the score 93.69. Okay. Next, we can evaluate the model. The final step. Okay. Evaluation of model evaluation. So model evaluation. Final step. The final step. I'm just taking the code over there. Model evaluation. Final step. To evaluate the performance of my algorithm. This step is important. Compare how we will use different algorithms per algorithm performance. Right? On particular regression. Okay. So what we'll do, we have to import matrix. Import matrix. So from sklearn import. Oh, I'm just writing in the markdown. So sorry. Started delete this one. Input matrix and print the mean absolute error. Write matrix dot mean absolute error, and have to provide y test and y print. Test comma y print. The mean absolute error is 4.18. Okay. We can also understood that how much error is there, how many errors, how much errors is there inside that model, right? So mean absolute error we have performed. Okay, and also we can do one thing that we can also export the model. We can also export that model. So just write we have to export our model with job name. It is used to export so it is used to export the model for later use case. So job lib, you can see, you can go over there and also search job lib. So you can see job lib running Python function as pipeline job. So you can also export your model with a job lib. Just go to the documentation part. Okay. You export your model. So all the documentation is there. Just copy this link and here I'm writing the link. So it will directly go on this side. First, we have to import. Sorry, it's not right in the markdown cell. So input our job lib, import our model. So import job lib. Have to input that. You have imported successfully. Next line, job lead dot dump, and your model is regression, right? Regression, and you have to provide the path. Copy path. This is the path. Here you can write this path or do one thing. So path is not matching. So we have to provide the file name, and this file name should be linear regression, regression model. Yes, okay. This is the format, SAP format, and file name. Okay, just write over here and oh, sorry, it's not here. Yeah, file name, and your model is saved. Okay, you can see the model is inside this in this folder, right? .sav. We successfully exported our model. So we write print successfully exported our model. Can run. Okay, so if I will see, you cannot open this one. Next task is that our model I have, so this is my regression model, right? I exported. Now from that exported model, we have to test that 9.25, whatever the hours. Then we can understood that our prediction is okay, right? So exported model, and then we can. So next step is that we have to write over here. We have to test our hours with the help of exported model. Now we have to test our model. Test our prediction with the exported model. Exported model. Okay. So exported model and you have to supply the relative path. So here I am copy the relative path, okay, and paste over here. Exported model, you have to import over there, right? So you can write import model, imported import model, okay, and your regression model I am creating over there, okay, and linear regression model is equal to what we will write job leave dot load. You have to load your model, okay. You can load, you have to load your model and paste over there this model, okay. Our model is done. Now we have to predict. So go this total cell, copy this one and paste here. And instead of regression dot predict, I am write linear regression model and load the model. Or you can write load model, okay. You can load the model and you can regression dot instead of regression dot predict. So instead of regression of predict, we can use linear regression this model, okay. And rest of the things are same, and we can also match that two values are true or not, means exact value, right? Now 93.69 exported model also says the same thing. 93.69 also we are getting, okay, from our exported model. So I hope we have done. So this is the step by step I have implemented in that the first task of that internship. So you can check, and I also upload this documentation and that notebook in my GitHub. So you can also directly download from there, and please subscribe and like my channels. And thank you everyone for joining the session. So I hope if you have any doubt, any questions, so please let me know through the comment box. So we'll definitely address your concern. And once again, thank you very much. And please subscribe my channel. Thank you.